All good with me.
All right, sweet. You should be good.
Cool. Hey everyone, my name is Justin Opini. I went to Clarkson. I was born in Nairobi. I guess a few cool facts about me. And I now work at Google in the Chelsea office. So today I wanted to talk a bit about developing at scale. Just because I think I can offer some insightful perspectives in terms of disconnects in terms of like curriculum versus like what you'll be doing on the job and et cetera, et cetera. I have a few technical slides in here, but I'll try not to make it too technical so that everyone can follow through. Really, all I'm trying to do is like get to you like the big points of like this talk. Like don't worry so much about like the smaller details is like the point. But with that, let's get started. So there will be a background. Before I finished up my senior year, I had the opportunity to get about a year's worth of work experience, which I really appreciated. So I started off doing summer research with the Barnages in TAS, my first summer. And then my second summer, I was able to intern on Google Play Growth. And that was a great opportunity. Play is a huge, it's a huge organization in general, but it's pretty important to Google in terms of what we're trying to do. And it was great. It was great experience in terms of like being able to like write code that potentially millions and like even billions of people could like see. And all in all, like it was a good fit in water test kind of. But I didn't like get too much done. Like for me, like that was mostly about learning. Like I wouldn't say like I contributed a ton to the team. And then afterwards, I interned at Google Test Data Platform. From there, I was the author of something called joint sampling, and that's majorly pipeline work. So thinking of like how do you sample from billions of records, a few records that give you the most coverage of the data you have while maintaining relationships. And so that was like a great experience. I think I knocked it out of the ball. Like I did much better than I did my first internship, and I loved it. This was in New York now. The first one was in Mountain View. And then I got to intern at Mongodb, which is a database company. They provide NoSQL databases. And that was also a great experience in terms of like trying something smaller. Like they have maybe 5,000 people, which is still like a huge company, but compared to like Google, where like there are 100,000 like employees, like much smaller, much more tight knit. Loved it, but ultimately like I wasn't the right choice for me. So I came back to Google afterwards for full-time roles, and I've been working on Google Ads optimizations for about 3 months now. And so Google Ads optimization, our goal is to give back to advertisers the most return on investment they can in terms of the advertisements. So this is like in providing smart recommendations and things that they can do to improve their campaign. And you can actually use this if you create like an advertiser account and try and run an ad or something. There are usually like free credits and stuff. Like I don't know, like it could be something good to play with. But yeah, so far loving the team, loving the work, and I've been here since yeah July, early-ish July. So diving into the talk. I thought this quote was pretty funny. We've all said this at some point. It works on my machine. And this is kind of like encapsulating the difficulty in terms of making something that not only runs on different platforms, on different devices, on different form factors, like on mobile devices, on laptops, on on smart devices. Like there's so many devices that you need to consider in terms of making a product now that this just definitely doesn't fly, right? You need to be able to write code that not only is inclusive to the people who use it, because you don't want to write something that for example, has biases towards, like, for example, a good example is the Pixel 6 just came out, and a big deal for us was we increased the data set of people of color in terms of taking pictures by 5 times. So the Pixel 6 is much, much better at discovering true color tone. So that's kind of what I mean in terms of like inclusive products. Like you have to be both make a product that works for the people and as many people as possible, and for the devices and as many devices as possible, which isn't an easy thing to do, clearly. Um, so thinking about my experience in college and what I do now, I came up with a list of things that I thought was super different in terms of like I felt that wasn't super representative in terms of what you do on the job. One of the things is readability often matters more than performance, right? Like I feel like once upon a time, yes, like RAM was like a megabyte or something, and you had to like really squeeze out performance as much as you could. But now compute power is so cheap that often like what you're trying to optimize for is your fellow programmers who like hiring people is not cheap. So often, like if you write smart code that only you can work on, that isn't as useful as writing readable code that potentially thousands of people can work on and understand. There's also like no individual projects. Like even if you start and even if you start something yourself, like at some point down the road, someone else will write code for that project, right? Like the intellectual property belongs to the company in most cases. So like like eventually someone else will have to work on your code. So you have to consider those future people. Um, Second is coding is often a side effect, not the goal. I actually think about CS as problem solving, and I think like if you're in the computer science curriculum, like you'll have to take like discrete math, you'll have to take a bunch of like other classes that aren't necessarily like coding classes. And I feel like we often get lost in the coding aspects of it when really the coding is a side effect of the problem you're trying to solve, right? Um, for example, Google will solve the problem of how do you find information on the internet, and like everything else that was built around that is to solve that problem, and not vice versa. If you get what I'm saying, like the priorities should be in terms of solving the problem and not the tools to solve the problem. And then third is testing is uber important. I don't think I ever wrote testing code ever in like a college class. I like you just never you run it, and if it works, you submit it, right? Like you actually have to write tests, integration tests. You have to write A/B tests. You have to like think about how do I prevent wrong extensions of my work, and how do I help future readers understand how to call an API. And then you expect way more roadblocks, right? You like going back to these normal individual projects, like everyone is invested in what you're doing, and that means you have to get buy-in from different places. You have to run things through legal, you have to run things through privacy, you have to run things through security. Um, and you often depend on like other people who are working tangentially to you. So sometimes you're blocked on something, sometimes you have to wait until a certain portion of work gets done. So it's a lot harder to kind of just dive into something in a day and just like I know do a 24-hour like lock yourself in and finish something, pump something out. Like that just doesn't scale or work, and nor should you work-life balance is important. And lastly, meritocracy is a real thing. Like, you should expect to be treated by your merits, which sounds intimidating, but the thing about this is it's not a test, right? You can ask for help. You can be like, I'm blocked on this. How do I move forward? And so you have to pick up other skills in terms of moving project management. You have to pick up all these other things to push yourself forward so that you can present the best foot forward, and by the aspect have better merits. Cool. And if anyone has any questions, feel free to jump in. I have 9 slides. I expect this to last maybe 20-30 minutes, and then open up for Q&A. So absolutely feel free to jump in if you have something to ask or add. Cool. And so jumping into a few technical slides, going back to thinking about how do you develop products at scale, you have to first consider that you have a multitude of programming languages out there, and there are better tools for doing different things, right? And there might be libraries that are supported in one language that are not supported in another language. There's this whole complexity towards picking the right tool, that often you have to consider how they'll interact. And so the first thing I want to introduce to you guys, if you haven't heard about this, is protocol buffers. And so if you've heard of the JSON format, it's kind of conceptually the same thing, right? You can write a JSON and then read it in a multitude of different languages. But protocol buffers offer a couple of different advantages. One, they're compilable code. So it's much faster in terms of setting things and getting things. They tend to be much shorter because they offer factory methods. So instead of being new animal with a species argument, then you can be animal.newBuilder.set species. It's just way more readable to read. It's way more scalable in terms of just in terms of the systems that need to for example, the pipeline example, writing code that writing a pipeline that you expect to potentially handle billions of lines of code. You can't do that in JSON. It just doesn't scale, right? So you kind of need the right tools for it. And so protocol buffers is something that Google authored, but it's very much open source, and I added a link at the bottom. So if you have some time and you're interested in checking this out, you should definitely. How it works is it actually generates the code for per language, and there are a multitude of languages supported. So this is kind of the first piece of the puzzle in terms of developing at scale, is considering how different pieces will talk to each other, right? And as of right now, I think this is the best way. This is the most scalable way. A bunch of companies also use this. I know Spotify does. Yeah, and that if you can follow the diagram, you can see you only have to define it once. You state what's in the data structure itself, and then the compiler does all the work for you in terms of generating the code for different languages. So you can use it in I used Rust and Kotlin there, which are pretty niche languages but supported. Yeah, and they can just be in absolutely different languages but speaking the same thing, which is awesome. And then the second piece of the puzzle to this is thinking about how architecture has developed in terms of what's standard in the past decade or 2 decades. I think we all pretty much have written monolithic architecture in one way or the other in school. It's you write the main, and that's the entry point, and that's the only entry point. But the thing with that is that there's so many points of failure in terms of if, for example, one thing in your app is eating up resources in terms of like memory or disk, then like potentially your entire app can go down. And so it just makes more sense to kind of make mini apps that are standalone build units that can kind of scale on their own. That way, like for example, if you have like a payment service and you have, for example, serve the web pages to use a service, like those two probably have different requirements, so you can do different horizontal scaling for them. And then you have to have a load balancer or like an entry point that like matches different like services, and then different services can call each other, and it just scales better. And like with at the bottom there, like that's the representation for like databases. Like you can have replicas for your databases, thinking about like eventual consistency, like how eventually they'll be the same, but they don't have to exactly be the same all the time. And so you kind of make all these compromises to make sure that your app is up most of the time. And if you have an issue, then your issue doesn't take down your entire thing. And so that's also important to think about. Again, this is something that's open source. If you've written Python code, the dialect will be very similar. Like it was derived from Python. It's a way more stripped down, simpler version of it. But you can again write build units for like a multitude of different languages in Java, in like C++, like all these like different languages, and you can get them to talk to each other, and you can get them to call each other without really having to think about what they're doing, like how they're communicating, which is awesome. And then lastly, this is like my last technical slide. This is covered a bit in software design and development, the class. But something that's super important is just source control. You have to think about how your code is being shared. I have a couple of links if you want to watch this afterwards. There are different talks about how Google does its repository system. We have like our own proprietary repository system, but the talks that have been given. I don't know how I can write this to. I'll figure it out. I'll send something to.
You could send the slides to me after the talk, and I could just share them with everyone.
Right, that sounds good. So basically, Google specifically has like a monorepo, which means we basically store all our code from like everywhere in one place, which is hard to do when you have like billions of lines of code, right? And the intention of like repositories of source control is you're supposed to download a copy to your local device, and just logically speaking, you can do that for like potentially like petabytes of data, or like an insane amount of data. So microservices help with that. Like with Bazel, you only have to pick up like one buildable unit, and you can work with that without having to think about how it interacts with everything else. But really, source control isn't that hard. If you haven't played around with source control, you can get a free GitHub account and just try a couple of like command line codes, or try a project with your friend and like try try using GitHub and checking in code. I think that's super different. Like I feel like with school, you kind of start a project and try and do it all locally, and then submit the project without really having to think about like the different versions you're in. It also helps a bunch in terms of just restoring something. Like if you messed up your code was, like you could go to a previous version, etc., etc. Source control itself is fairly complicated in terms of like the theory of it, but like the tools that you use to do it are fairly simple. And I think it's good. It's a good thing in terms of like the abstracted difficulty of it. That's why I have the meme on there. You kind of just have to know the commands you're used to using. but other than that, you don't have to like think about it too much. I think the important thing of source control is code reviews. This is like you send someone your code, you ask them to comment on them. They go through your code, they add a few comments, you work with them, and that's like how you collaborate with someone in terms of like your own change and them adding their opinion. And this has a few different advantages. One, it's just easier to find errors. I feel like if it's your own code, you're too in it, like you often miss different things. Secondly, you remove individual biases. You might have made unverified assumptions while writing the code that someone can quickly correct you on. And thirdly, like it just leads to better quality products because different people get to chime in on your change, and they get to be like, hey, maybe you could do this in this way, and overall, a better product is equals to happier users. So you can do this on GitHub again. Like if you haven't like messed around with source control, you can try changing. You can try sending like a pull request to someone and try making a change. But yeah, that's kind of like all I had. It's like uh, you really like again like I emphasize this like I love to think of computer science as problem solving, and all these are just tools to solving a problem. Like if someone had like better ways to do this, you absolutely go for the better way. And like in terms of developing at scale, you just kind of have to think about reliability. You have to think about the scalability and flexibility aspects of it, and you just have to think about the ease of mind, right? Like it's just easier like having the systems in place that even if you are writing code for just for Java, you never know what you might be doing like 5 years from then. Like you might need like an extension of it in Golang or something. So yeah, just recapping. Um, if you aren't too familiar with the concept, just look into protocol buffers, microservices, and just source control, and like maybe like try and do like a small app or something, a small project. And I feel like those are super transferable skills in terms of being able to use those tools. Cool. Does anyone have any questions, additions?
Thank you for that talk. I guess now we can open the floor up to a bunch of questions. So just anything at all to do with computer science and development
Right.
and career stuff. Just everyone, just unmute your mics and just start asking Justin your questions. I have a couple questions myself, but we can wait until other people have asked something.
Sounds good.
Hi, Justin. I think I'll ask a question first. I think I saw that you obviously said that you're working on like Google Ads optimization now, but I saw that you mainly work in like back end software. What like technology are you using exactly, or like what I guess language would you be using for that sort of stuff?
Right. I'll say if it's written in Google, it's a good bet. It was written in Java. So this is the first team I've been on that's full stack. So I actually do on occasion like write some front end code for that, and that's actually the first time I've done that like in a job position. So we own everything from like the servers to like what the users see visually. And so like our stack is Java, Dart, like Angular, Dart. And then apart from that, we use like the things I've been talking about, open source. We use protocol buffers for like data structure management stuff. We use in terms of like databases, we have a couple of like databases that are available on like Google Cloud that you might be familiar with, like BigQuery, F1, etc., etc. Databases in general tend to get complicated, but yeah, I think that's pretty much our stack. We have a couple of proprietary database stuff in terms of like the lowest layer, and then we have a bunch of Java server code and then we have like Angular dot stuff on top for what the user sees. Does that cover your question?
Yeah, I think so. I guess this is like a side comment. You guys are using Angular. I just know that React is like a very popular JavaScript framework that like most companies are using. Is there like a certain reason that Google find Angular to be useful? Or is it just kind of like a preference? Is it just like a preference of the company, I'm guessing?
Yeah, I mean, I've used React, and I actually do prefer React to Angular. That I think it's just more of a control thing. Like we can like pretty easily change the direction of like where Angular is going because we write it and like we publish it. Versus like if we used React, like we will be at the mercy of some other company, in terms of like features we will need or like stuff like that. It will just be more friction, I guess. Um, so yeah, I think it's just more of we like to dogfood the things we make. Like we like to use the tools that our users use.
Okay, yeah, thanks.
Feel free to like ask me non-coding things too. Like like yeah.
Can you talk about like how you got your internship with Google?
Yeah, totally. Um, yeah, I think the first time I just applied online. Um, Actually applied the summer before, but I didn't get it, and then I applied online. I I can talk about the interview process. Like you basically do a phone interview for 45 minutes, and then depending on like what you're interviewing for, you might get to go on campus in like a non-COVID world, and then you get to like meet engineers and you get to like whiteboard and like work on problems together, and then after that they evaluate your fit, and then you either get an offer or don't. So for me, it was like pretty straightforward. Like I applied online, I did the interviews, and I did well enough to pass the interviews. From my first internship, I've never had to do like another interview for Google. But yeah, so I kind of just slipped in is how I like to think of it.
Did you apply for STEP first or did you apply for SWE first?
So yeah.
Did you apply for STEP or engineering practicum first or did you apply for the software?
Yeah. Back when I did it, they called it engineering practicum, and I did that fast, and then I transitioned to the SWE role afterwards.
Could you elaborate on what the differences are?
Yeah, totally. Functionally, it's the same program. Like you, as an engineering practicum, you get more support. Like you have two hosts instead of one. So you get to the ability to ask two different people like questions and like work with them closely, which isn't like a bad deal. And then you also get another intern. You work in twos, which is like they call that pod, I guess. But yeah, functionally you do the same thing. Like you like both SWEs and EPs get a project at the beginning, and they're supposed to like you might get like smaller projects to warm up, but like generally you get like one main project to do. And with EP, I guess step now you just get more support in doing that thing. You could talk about your experience, PJ.
I'm good, thank you, though.
Could you describe what it's like an average day at Google, like working on stuff, like what that's like? Just walk us through that.
So, I guess I could go through today because it's the freshest. We typically try not schedule meetings before like around 11, 12-ish, just because people usually tend to start later in the day. So I like that flexibility. So I know. We depends on like now you can work from home, you can work from the office. Like sometimes I go in, mostly just for the lunch, but yeah, depending on what I could either like work from home or work from here, and then once I typically I like to keep it meetings light. Like I like to like stack up my meetings on one day. That way like the rest of my week is like dedicated to like personal work and stuff, or like meeting one on one with different people, like stakeholders. Um, I also like there are a bunch of fun activities in between there. Like for example, before this, I was actually in a poker game, which I actually did really well. Um, but yeah, you like the tons of like social stuff we do in between. Like we have game rooms, we have like different like things that you can take time to unwind if you just don't wanna work on something at the moment. Yeah, and that's pretty much it. Like you either are coding a meeting, yeah. So it's fairly normal job, except that I feel like you get way more freedoms in terms of like they trust you to like deliver on your work. Is yeah.
I guess one thing I'm curious about is when working with other people, um, like how do you like match up with their workflow? Do you just set up meetings with them like asynchronously and give them like, oh yeah, can you look this over? Or like do you like do pair programming type stuff? Like how does that generally happen, that collaboration with people?
Right. This like depends on like what level you're in. Like some levels like are expected to be like more independent than others. Like that's like just the nature of like progressing up the career ladder. Um, Pair programming is a thing. It's just not super common, I guess. Um, but typically, collaborating with someone means like the easiest way to get buy-in is to write up like a document or like a proposal of some kind, and then invite them to like comment on it. And then afterwards, like when you set up like that 30 minutes or so, like one-on-one, then like you both done like enough work beforehand that you're really just like checking boxes at that point. And then you can like sometimes like it's appropriate to do like a small prototype of something. That way like they can see where your head's at and like what you're thinking about, and then you can chime in. So it's more of like collaborating with someone. I guess at Google for me is more of like you have to put in like the initial effort to like make their life easier in terms of them working with you.
All right, thank you for that one.
No problem.
I guess one other thing, what besides all that you've talked about, what did Clarkson definitely not prepare you with their classes for that you kind of had to like figure out a lot of?
Totally. It's a good question. Definitely like just like like project management skills. I feel um, in terms of just managing your workflow and being able to like push things. I feel like there wasn't really a class for that, right? Like I did computer science with a minor in math, so I never really like took a project management class or anything like that. But I guess like if you did take the class, that will be useful. So that was more of a I didn't make use of the opportunity available to learn like the project management skills, but I was able to pick it up after some time. But I guess like that definitely was like the biggest disconnect for me, like being able to just take charge and being able to own the things that you do.
All right, thank you. We have a question from Derek Taylor, who couldn't say their question out loud because their roommate's sleeping. And the question is, what is one of the biggest takeaways or things you learned from your first internship?
My biggest takeaway was definitely that I dealt with a lot of imposter syndrome, like my first internship. Like, I definitely didn't feel good enough for the job, which is like a roundabout way of thinking about it, because if you got the job, then you are most likely qualified for the job. But it's definitely something I had to walk through. Like, it's definitely something that everyone has their own way of dealing with. And my biggest takeaway was everyone has their way of contributing. Everyone has like the things they're good at. Everyone has like the moments they shine in. Everyone has like a way they can chime in. And all you can really do is try and see what happens. So my biggest takeaway, I guess, is like how I deal with imposter syndrome is just putting your best foot forward and seeing what happens. And that helped a lot. Like, definitely like lots of like smart people around. It can be intimidating like all the time, but I guess you just think about it less.
Thank you for that response. I have one question about time management. Would you say it's much easier to manage your time with your job at Google as compared to like classes at Clarkson and like college? Like, is there like a just big difference there? Like,
Yeah. I get to not think about work when I go home. Um, but yeah, I think like that's the biggest difference. I feel like schoolwork follows you everywhere, versus like I like once I close my laptop, right? Like I'm probably not going to look at it until the next day. I can just turn it off, and it's never that big of a deal that you need to like get it done then and there. And yeah, like deadlines are flexible, so like the like totally accounting for like life events and everything. So like in general, like way more flexibility. Therefore, like I feel like it's been way better in terms of like my work life, or I guess school life balance.
all right, thank you.
No problem.
I have a more of a lighthearted question.
Go for it.
What do you like to do for fun?
I like to travel. I'm going to Seattle for 2 weeks. After like from November 1st. Yeah, I like to just see new places. I've never been to Seattle. Um, I like to try different foods, like see what like that specific. I feel like all towns or like all like places that have like their unique thing. So I guess like finding those unique things and like finding like all the people you meet like along the way is super cool. So I enjoy like, yeah, off the top of my head, yeah, love traveling. I'm glad we can finally do that with like COVID getting better and everything. Yeah.
Yeah, I'm sure it's still hard to like get around like to any foreign countries or anything like that. But it's getting a bit better. It's getting a bit better.
Yeah. Hopefully.
Yeah.
Cool.
Do you like commute or do you like live in the city? Like what is that situation? Also, have you lived in the city before, or like have you been in that place? Like, how long have you been living in near the city and stuff?
Yeah. I took like spring of my junior year off and then walked through the summer. So and both of those were in New York. So I guess I had lived in New York temporarily for like 6 months before like this. But right now I live in Williamsburg, which is in Brooklyn. And my office is in Chelsea, which is like on the other side of Manhattan. And it's like 15 minutes, like door to door. Like I just hop on a subway, and then I'm there. On the subway, yeah, it's really close both ways, like to the office and my apartment, which is why I love New York. Like the public transportation is just way better than anywhere else.
This is it's kind of like a futuristic question, but not really. I recently got access to GitHub Copilot, which writes code snippets for you in line,
Right.
and it's actually not bad. And it makes me wonder, kind of like, do you think the types of skills are gonna change for programming? Like, there's gonna be less emphasis on the actual code writing, even more so, or like, how do you think that might change programming careers in general, and like career paths?
Right. If I had to speculate, like I think like some aspects of like coding will change. I feel like we'll do the less tedious stuff less, right? Like I feel like the easily verifiable stuff like will outsource to like automation in some way, but I don't I think like coding jobs are here to stay. Yeah, like I'm not too worried about like software engineering in terms of like automation taking away jobs. If anything, I feel like we would need more people to like make sure the systems are actually doing what they should be doing. Um, but I don't know. Like I feel like I'm optimistic for what it will bring, but I feel like if anything, it'll take away grunt work and like the tedious bits. But like they're just things you can't teach a computer to do. Like for example, like I wouldn't expect a computer to write pipeline code reasonably well, just because it's just so different from like how you write normal code. Um, yeah, but that is cool. Like I am interested to see how good Copilot is.
Kind of going off that AI question, I know a lot of companies, when it comes to like using like mainly I think like advertisement algorithms, are using a lot of like machine learning technology. Is your group kind of working on anything similar to that?
Yeah. On the external team, yes. Like we have like a smaller and like larger team. Like on the extended team, yes. In my immediate vicinity, no. But yeah, they're definitely like I think Sundar has said this a bunch of times, like on like articles and like interviews that like we're trying to be an AI fast company, which I think is a very smart move. But lots of like different products use ML in different ways, from like photos to like ad recommendations to rankings to search to if you can name the product, like in some way ML is probably a factor.
Cool, thanks.
No problem. I guess as time is running out, can I ask you guys a question? What's everyone thinking about like after graduation? Is anyone interested in doing software engineering as a profession?
I mean, personally, I would hope so. It's my degree. I'm a software engineer. I mean, I think me personally, I kind of see myself going towards full stack. I'm not sure if it's going to be at Google or some other place, but if it's working on like mainly full stack for some sort of website, I think that's very like applicable to like a lot of scenarios. So
Right.
that's me
Cool.
at least. I don't know about everyone else though.
Cool.
I know I'm considering, I'm like kind of like on the fence right now, like considering between research and industry, because like a PhD seems really enticing in terms of, oh, I get to deal with artificial intelligence more and more, and sort of the intricacies of that, but also the freedom that kind of just not being in a PhD program allows is also really cool. So I don't know. I'm just kind of like weighing the pros and cons, and I'm still considering what I want to do. But I'm definitely interested in working at somewhere with like software engineering. I just think it's so cool to just make a complex thing with a bunch of people together and sort of just have it work, and then it affects a bunch of people. I think that's pretty cool. That's one of the things that draws me to like software. So, what does everyone else think about their after graduation prospects?
Well, for me personally, I am kind of going into somewhat research-oriented software engineering, so I think it's kind of like the best of both worlds. I can still kind of do some research, while still kind of actually working on products that will help people and affect things.
Yeah. And there's always like industrial research too.
On that topic, what do you like from an industry perspective? What are your thoughts on grad school and seeking higher education in CS?
Personally, not for me. I kind of had my fill of school in the 4 years of undergraduate, but I think like some people are just really suited for it, and some people they like thrive in like that research like environment of like writing papers and like pushing the edges of like computer science as a field. I feel like we couldn't go anywhere without people like actually making the theories for like the implementations, right? So I like I'm if you think it's the right move for you, right? Like I feel like everyone is wired so different that it's hard to give a blanket recommendation. I just feel like there's a right call for everyone. So well, if anyone has any more questions, you can reach out to me on LinkedIn. I think Alif has my LinkedIn. He can.
Yeah, I'll send it in the Discord to everyone after the talk. I did have kind of like one more, I guess one more kind of like speculative question.
Okay.
How do you think like the collective impacts and like convergence of technologies like AR and like virtual reality and like kind of how technology is going to shape our future just collectively as a species, like because you're working kind of in the heart of that, you might have, I don't know, I just like to hear your ideas about
Absolutely. Yeah, I think augmented reality and virtual reality is for sure the next step. I think like the technology is fairly young. Like I feel like um, by the time like it gets around to be like generally like usable and available, like we all will be like old people for sure. um, but I think like the early stuff is still pretty cool. Like I think Magic Leap is doing some pretty cool stuff. I think um, like Oculus is doing some pretty cool stuff. I think like there are different people like making some good moves. Um, but immersive is always the way to go. Like I took human computer interaction, like the class, and like there are definitely like differences between like strong and weaker interfaces. And while the form factors we've had now have worked for a long time and they've worked really well, maybe there's a better way to do it. So I think all we can really do is invest more and see where it'll go. But I definitely think like it's all exciting stuff, and I think like we're like that definitely is like the next step in terms of immersion.
Thank you for your input. At TARS, we're working on this project for teleoperating drones using VR. So there's just a lot of cool things that I think are just gonna kind of be brought out in the fore in terms of possibility, because one of the limitations of a lot of our information technology, it's just not aware of the context. Like your phone is not aware that you're like in a cafe, or like, I mean, maybe a little bit in terms of like geofencing, but not like what you're talking about to who directly. And so I think there's a lot of cool like directions for software engineers there, but like you said, I think it's definitely in early stages. So.
Totally. A little shameless plug. The Pixel 6 actually does really well in context understanding. Like you can do some fairly complex like speech stuff and it'll like understand you. Like you can like put down emojis, you can be like delete this and it'll actually delete the word. Like I feel like that there are definitely strides being made in terms of like better context understanding.
I saw a quick clip of it, like kind of doing like that Photoshop, like remove and fill feature automatically, like through the camera app, and I thought that was really interesting because I'm guessing
Yeah.
there's like some sort of like under level AI like filling in what you want to take out of the photo, and that's like really cool. I think so.
Yeah. And it's like
Take that, Apple.
yeah. And I say this as someone who loves and uses Apple devices. I still think it's pretty cool. Cool.
All right.
Awesome.
Yeah, if anyone doesn't have any more questions, we can let Justin go back to the realms of New York City.
Yeah, thanks so much everyone for hopping on the call and listening to me.
It's great to have you.
No problem. All right. Have a good rest of your days.
All right. You too. Have a great day.
Cool.
Alif, I feel so dumb.
Why?
Because Angular is developed by Google. I'm so stupid. I'm so dumb. I was like, why are you guys using Angular? And then I looked it up. I'm like, oh, fuck me. Oh, my God.
Hey, it happens. It's kind of embarrassing, but it happens.
I think he had. He had a notice. He works there, but because I knew like React was done by Facebook.
Yeah.
I didn't know Angular. Whatever. That's funny. I was as soon as I looked that up, I was like, God fucking damn it! I'm so bad at this shit.
Well, I
All right,
hope you
whatever.
I hope you enjoyed the talk. I think it might have been helpful for some people. So
Oh no, I thought it was great. I was taking notes honestly during it.
so yeah, I'm planning on having a bunch more people eventually, depending on who I can get in. But it depends on also what people want to learn about. But definitely a bunch more interesting speakers I can try to get in. I think I really want to bridge that gap, because Clarkson just does not teach you all the things you need to know, and then you go in, you're just like, what is GitHub? What is
Yeah, it's classic. He was basically even like turning today. He was like, "Yeah, I had to write a bunch of test cases, and I like never did that at Clarkson." I get that.
It's yeah. Well, I'll
Yeah,
I
thanks
wish
for getting
you.
that to work. That was sick.
Yeah. Well, have a good day. I gotta go do some studying now. So
Yeah, same. We had that the automata exam tomorrow, right?
yes, we do. That's gonna be fun. So
Yeah, exactly. I don't know. I saw the practice exam. It seems if he's like the kind of professor that like has exams very similar to practice exams, I think it should be fine.
yeah.
That's exactly what the last exam was.
Yeah. So it's I think we're gonna be good here. So
All right.
all right.
Yeah. See you then,
Goodbye.
I guess. See you.